Hello, my name is Benjamin Sanchez. I am a professor of the Technological University of Monterrey in Mexico. Also, I am an Energy Council of Canada Research Fellow. I want to give thanks to everyone for being present. Today, I will show you some parts of my research work entitled A Building Information Modeling Approach for Adaptive Reuse of Buildings. This is a brief outline with the points in this presentation. A shift of thinking in the perception of sustainability in the construction industry has arisen in the last decade, switching from the traditional, creative, and innovative approach towards a restorative and regenerative one. This change of perception is founded in the facts that an enormous proportion of extracted materials along human history are in today's built environment, and it's going to keep increasing in the coming decades. The turnover rate of the building stock is low. Therefore, we cannot just rely on new construction solutions. The relative importance of the extraction and construction life cycle stages have increased because of the reduction of the energy loads in the operational phase. And finally, the price of materials extraction is increasing, as is the negative environmental impacts due to natural constraints. To remedy this situation, the construction industry is implementing designs and systems with improved life cycle performance. The main objective is to consider closed-loop cycles. The principle of closed-loop cycle aims to keep products, components, and materials at their highest utility and value as much as possible in order to create sustainable cycles. One example of these trends is product recovery management. In this matter, adaptive reuse of buildings has been identified as a superior alternative in terms of sustainability and circular economy. It involves restoring, and in some cases, changing the use of existing buildings that are obsolete. Adaptive reuse is considered a disruptive practice in the current capital project delivery model for the renewal of today's built environment. In a life cycle perspective, adaptive reuse has the potential to maximize the residual utility and value of existing assets by giving them new life through PRM methods such as selective disassembly and deconstruction planning. The development and implementation of a building information modeling approach for adaptive reuse has the potential for optimizing the project outcomes in terms of life cycle. However, current BIM models do not support important project activities for adaptive reuse, such as disassembly planning, product recovery management, or parametric design to integrate recovered products. Therefore, in this study, we developed an integrated BIM process model for adaptive reuse project execution planning. In this approach, we take advantage of the intelligent 3D model-based processes of BIM for adaptive reuse projects. Also, based in the experimentation and analysis of previous studies, we identified critical needs and requirements for adaptive reuse BIM models. For example, for the adaptation planning phase, it is necessary to define an appropriate level of detail in order to make the model compatible with disassembly planning theories. For the selective deconstruction stage, it is necessary to set the construction interfaces between building parts for choosing the correct deconstruction methods to apply. For the renovations stage, it is necessary to develop an accurate as-built model in order to fit new or reused parts into the new design. This point is related to the determination of the level of tolerances between the physical interfaces of the existing parts and the new additions. For the first example, we developed an automated script to add meaningful information to the BIM elements during the modeling process. This information is fundamental to compute the disassembly planning of target components, such as type of part, disassembly part ID, and hosted components. For the second example, We developed an automated script in order to extract relevant information from the BIM model for the deconstruction planning. This information is necessary for determining the deconstruction sequences of target components to retrieve, such as motion constraints for components and extraction directions for connections. With the information generated and retrieved from the BIM model, now it is possible to apply methodologies for selective disassembly and deconstruction planning. These methodologies create the optimal activity network and disassembly sequences to retrieve components based on physical, economical, and environmental constraints. These are just two examples of several needs that we have pointed out in the full paper. There are more stages in the process of adaptive reuse that must be covered in the future research, such as managing and undertaking the activities for the construction and renovation works. We are living in an era of technological advancements that are making possible the improvement of buildings' performance along all the life cycle and along the entire construction supply chain. For example, it has been demonstrated that digitizing building information is reshaping the ways for delivering buildings. Digitizing the built environment is leading to a greater integration across practices and scales that were once considered separately. This integration is helping to create technical solutions and new functional business models in the field of circular economy, with the purpose to move towards a more sustainable environment. The framework developed in this study helps to understand how to effectively tackle some technical and execution barriers by complementing the information included in the current BIM structure. In this study, we demonstrate with functional examples the possibility of complementing this missing information in BIM models for adaptive reuse. Thank you.